Not everything can be simplified. In mathematics, most strings cannot be compressed into a shorter description. Only special cases with patterns allow that. Physics works the same way. When a system is simple and structured, we can describe it with compact laws. When complexity increases, that simplicity breaks. New behavior appears that cannot be reduced to the original description. A physical law is a compression scheme. It summarizes regular patterns in a system. When a system has symmetry and redundancy, you can compress it into a short equation. But when interactions multiply and symmetry breaks, compression fails. The law stops being sufficient because the system no longer follows a simple pattern. At that point, you need a new description. Some examples follow. Since the hydrogen atom is highly symmetric, the Schrödinger equation gives a clean and accurate description for it. The system is simple enough to compress. For diatomic molecules, the situation changes. New interactions appear, like electron correlation and molecular bonding. The hydrogen model cannot capture them. These are new collective irreducible properties. General relativity works very well in simple systems, like the Sun and Mercury. There, symmetry and low complexity allow accurate predictions. But at the scale of galaxies, it fails to explain rotation curves unless a fictional dark matter is added. That is a patch, not a prediction. MOND, on the other hand, captures these galaxy-scale patterns with a different rule. This shows that new collective behavior dominates at higher complexity. Strong emergence means new, irreducible properties appear at higher complexity. These properties were always present as possibilities in the interactions, but they only become visible as collective behavior. Reductionism assumes everything can be reduced to the smallest parts using one set of rules. That assumption fails. A finite set of rules can only describe a limited class of patterns. Beyond that, systems become irreducible, and new descriptions are required.